Welcome back, everyone. Today, we're going to dive into a classic SQL puzzle. It's one of those things that seems super simple at first, but has some really tricky edge cases. We're talking about finding the highest paid employee, not just in the whole company, but within every single department. So in our last session, we got the basics down, and I promised you we'd take that knowledge and apply it to a real-world problem, something you'll actually see on the job. Well, here we are. We're going to look at 3 different really powerful SQL queries to crack this nut, and each one has its own unique style and strengths. Here's our game plan. First, we'll set the stage, really define the problem, and see why the most obvious answer falls flat. Then we'll roll up our sleeves and dive into 3 solid solutions, using modern window functions, a classic subquery, and a really slick little method using tuples. And to wrap it all up, we'll compare them so you know exactly which tool to grab from your toolkit. All right, let's get into it. Section 1, the max salary problem. This is exactly where most people start, and it's the perfect way to see how SQL can sometimes trick you if you're not careful. So here's the request from your boss. It sounds easy enough, right? Find the highest paid people. But the devil is in the details. That little phrase, in every department, that changes everything. We can't just find the one top salary across the entire company. We need to do it over and over for each department. Now, if you've been writing SQL for a bit, your brain probably jumps straight to group by and the max function. I mean, it feels right. It's what those functions are for. You group by the department, find the max salary, but this is where we hit our first and very critical snag. So you write a query like this. It groups everything by department, and yep, it finds the max salary in each one. But look, you're also selecting the employee's name. What happens if 2 people in the same department have that exact same top salary? Well, the database has to pick just one name to show you. The other person? Poof, they're just gone from your results. And that's a big problem, because now your data is incomplete. And this is exactly what that looks like. We call it the missing tie problem. On the left is what our simple query gives us. It shows only one top earner for marketing. But the reality, the correct result on the right, is that 2 people share that top spot. We need a query that gives us the whole story every time. Okay, let's move on to our first correct solution. And we're starting with a modern powerhouse, the window function. Seriously, if you're not using these yet, you're about to have your mind blown. So what the heck is a window function? The easiest way to think about it is this. It lets you peek at a window of other rows without actually collapsing everything down like a group by does. For our problem, it's like we get to create a little temporary bubble for each department, find the max salary inside that bubble, and then stamp that max salary value onto every single employee's row within that department. It's incredibly powerful. The absolute magic is right here in this line, max of E.salary over partition by D.name. That partition by is what creates the window or bubble for each department. It finds the max salary for that group and then adds it as a whole new column, max salary, to every single row. Once you've done that, the rest is a piece of cake. The outer query just has to say, hey, show me all the rows where the employee's actual salary is the same as this new max salary column. It's so clean and it just works. All right, on to method number 2, the subquery join. This is a more traditional way to do it, a true SQL classic. You'll see this pattern all over the place in older code bases, and for good reason, it's rock solid. The logic here is kind of like a 2-step dance. First, we use a subquery as a little helper. It goes off and creates a temporary table for us. Think of it like a cheat sheet that has just 2 columns, the department ID and that department's max salary. Then, our main query takes that cheat sheet and uses it to find all the employees that match up. If you look at the code, you can see that subquery right in the middle, which we've named M. But the real secret sauce is in the on clause of the join. We're not just matching on the department ID, we're joining on 2 things at once. The department ID has to match, and the employee's salary has to be equal to the max salary from our cheat sheet. It's that double check that makes sure we only get the true top earners. Okay, our third and final solution, this one is really elegant, and you might not have seen it before. It's so concise, I like to call it the clever tuple. So what's a tuple? Don't let the fancy name fool you. It's just an ordered list of values. But in SQL, this lets us do something really, really cool. Compare multiple columns at the exact same time. So instead of checking if column 1 is in a list, and then checking if column 2 is in another list, we can check if the pair of column 1, comma 2 exists in a list of other pairs. This query is just beautiful. It's so short. The subquery is the exact same one from our last solution. It creates that list of department ID max salary pairs. But just look at that where clause. We're checking if the specific pair of an employee's department and salary exists in that list we just generated. It's such a direct, readable way to say exactly what we mean. And here's the key to why this is so powerful and not just a gimmick. The tuple enforces the relationship. It keeps the department and the salary locked together. It's asking, is this person in Department 1 and earning 90K? The wrong way, on the right, breaks that link. It would match an employee in Department 1 who earns 80K, which is wrong. The tuple is smarter than that. It preserves that critical connection. So there you have it, 3 fantastic ways to solve the exact same problem. Which leads us to the big question, which one is the best? Which one should you be using in your day-to-day work? Well, let's break it down. Window functions are usually your best bet for performance. They're incredibly efficient and are definitely the most modern SQL approach. The subquery join, though, is super readable. Its step-by-step logic is easy for just about anyone to understand, which is great for team projects. And the tuple method? It's the champion of being concise, though it might confuse some of your teammates who haven't seen it before. The truth is, there's no single best answer. It all depends on what you value most for a given project: raw speed, clarity, or just pure, simple elegance. And that's a wrap. We took a tricky, common SQL problem and broke it down with 3 powerful techniques you can start using today. So the real question I want to leave you with is this. Now that you've got the toolkit, which one of these solutions are you going to reach for the next time this problem lands on your desk? Thanks for watching.